Hello everyone, and welcome back to another video tutorial on WebGL. Today I'm going to be breaking the traditional graphics programming tutorial mold and talk about loading things from an external file. So here you can see in Blender I've created this mesh, which really is nothing fancy. I'm just taking one of Blender's default meshes, the monkey. You probably can't read this because I can't figure out how to make the Blender menus larger. And then I have this text right here that looks like some child just drew on it with a crayon or something. That's because more or less that's what I did. I just kind of used a paintbrush to make some things brown, some things white, and put some blue in there maybe. Why not give him some eyes, black? Yeah, not beautiful, but it'll work functionally for this tutorial. So I'm going to show you how to export a model from Blender and use it in a WebGL application that you make. And staying true to not using any external libraries, I'm not going to bring in a library to load the code. However, we are going to have to use a tool to convert it into a format that we're going to be able to use. So there's a library called ASIMP, stands for Asset Import, and that is used by C++, C#, Java, especially for loading models in from a wide variety of 3D formats into your OpenGL and DirectX applications. There's also an ASIMP to JSON tool, which is what I am going to be using. You can find it on GitHub. I'll put this link on the video description. And it will convert from any of these file formats, including a whole bunch more, 40 plus apparently, into a JSON format that mimics what ASIMP uses internally. So if you're familiar with using it at all, this shouldn't be too hard. I've used ASIMP before, which is why I liked this so much. We're going to be using the FBX format, and I have no good reason for you for that, other than it's just the one that I found the best luck with. I've been playing a lot around recently with skinning meshes and trying to get those exported in a nice, easy pipeline, but for some reason I can't figure out how to do it with the plain Blender files, and so we're just going to use FBX. So the first thing I'm going to do is I'm going to save this, a different copy of it, to the Git repository that I have been using, which is right here. So I'm going to call that susan.blend. So there's a copy. I'm going to save out the texture, which you can do in Blender by just image on your UV view right here. Save image somewhere, save as image. I'm going to call that susantexture.png. And I'm going to kind of just breeze along this part because these are not tutorials about modeling in Blender, so I just have something that I've made, and now I've exported the FBX file and the textures appropriately. And let me make sure that I didn't miss some option on FBX. So let's see. Looks like it, I'm pretty sure it triangulates. Yeah, we don't need any of that. Okay, we're good. So I'll just cancel that, and I'll close out of this. Apparently I'm going to save first. Great. So if you come here, there's you can download the Windows binaries, and it gives you a whole bunch of options. You want this, and it just has a .exe and a couple of DLL files in it. I've already downloaded it, so I'm not going to re-download it. I'm going to instead bring up PowerShell, and I'm going to the way that you use it is you find the ASIMP executable, which I know I have mine under F, downloads, ASIMP to JSON, release, ASIMP to JSON.exe. The second parameter is going to be the file you want to convert. The one that I want to be converting is under F. Let's see, game programming, Indigo CS WebGL tutorials, susan.fbx, and I want to export that to Indigo CS susan.json, let's say. So if I were in the local path of the repository, I would just say asimp to json.exe, second susan.fbx, third susan.json. I'm going from susan.fbx to susan.json. I'm not sure if you can read this right now because my resolution is really high and I can't seem to zoom in on a lot of these things. So after I've done that, I now should have a JSON file that if I open it up, here's my Susan texture JSON FBX. If I open this, yeah, so it looks like it got all the information right. We have roughly a jillion vertices right here. I don't know why there's so many. I don't know if I accidentally made a copy or duplicated the mesh or something, or maybe it's an FBX thing. It's not going to matter for this tutorial. We'll just be fine with it. Let's see, so let's do that so that we can read all this. Cool. Yeah, so I'm going to shut down this instance of the server. This is running the my kind of proof of concept. I like to actually write these all out before I record the video on how to do it, so I'm not just floundering here for forever. Let's update this, so rotating Susan. And I'm going to remove the crate image, because we no longer need that. So, just a second, let me actually remove it from the repository. If I can find it. I should have just had it open. Boop, 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 boop. Alright, so here I am. Here's a folder with a repository. So I'm just going to remove this crate.png. I am going to, since this is a video tutorial on loading things from external files, I'm not going to have an image tag for the texture. We're going to focus on that. And one thing I said when I started this is I wanted to use as few external libraries as possible. And the reason for that is I'm really not going into good programming practice, just because I want to make this as simple as possible so that you get straight to the WebGL graphics programming stuff. I'm going to make another exception to it, as I did with GL Matrix. And I'm going to just create a little util.js right here that's just going to have some functions that aren't really related to the graphics part of it, but that we're still going to need to load things, or to do certain actions. Yeah. So in this util.js, I'm going to be writing a couple of functions that we're going to use to load external resources. So one thing I'd like to do is I'd like to move the shaders into their own files. So I'm going to make a load text resource function. So this function will load a text resource from a file over the network. Oops. Our load text resource equals function. In order to load a text resource, we need to know where it is, so what the URL is. And then another thing that we're going to do is we're going to have a callback function. And the reason for that is, well, let's back up and talk a little bit about asynchronous programming. If you haven't done much JavaScript before, it's an asynchronous programming language, and very functional as well. So you can send functions as parameters to other functions. Now usually if you're doing C++ programming or something else synchronous, we would do a lot of works, lots of work, and then down here we would return something. So, you know, maybe we're returning text is, or let's not return an object. You'd return something like that. And if you had a problem, maybe you return error whatever. Or perhaps you throw new error whatever. New error. JavaScript asynchronous programming doesn't work that way because we're going to be asking for a request over the network, which potentially could take a lot of time. It could take in the milliseconds range, which is a lot of time for programming. So instead, we have this callback function that we want to use to return the value. We're going to call this callback function when all this work is done and we're ready to send the result back. The reason for that is one of the JavaScriptisms. What you want to do is you want every one of these functions to finish as quickly as possible. You don't want to hang up waiting for any other resource because JavaScript is single-threaded in its execution. Anyways, too long, didn't read. Long story short, you're using a callback to return your value. So instead you'd say something like this: callback success, or callback something, I guess would be what we had before. Now, another JavaScript-ism I'm going to introduce here, again, I don't want to get too far into the using proper technique and everything. Is something like this. So usually in JavaScript, I can't think of a good reason for this other than this is what people do. There's no like language imposition to do this. But your first parameter in a callback function is usually going to be an error. So if we do this, this means that there's an error that we're sending back. There was a problem that happened, and we need to notify them what the problem was with this first parameter. Then, if everything goes right, the first parameter will be null, and all of the other parameters will be your results. So, like, maybe this will be actual result, something like that. We're going to use that just so that our other code can notice if something went wrong. Great. So with that all out of the way, that took longer than I wanted it to. let's get to actually using the AJAX. And the way we do that is we create an XML HTTP request object, which this will be used to send a request back to our server, which in our case is also just our computer, for a resource. We open it and we specify which method we want to use. We're getting something, so we use the HTTP verb get to do that. We want to get it at this URL, and true. I believe this third parameter specifies that we want to do this asynchronously, though I'm not 100% sure. We then specify what happens when this request is finished. So we write the function that will be called when this request has been completed. And what I want to do is I want to say if the status is not in the range, in the 200s range, we want to return an error. If you haven't done network programming before, HTTP status codes from 200 to 299 in the 200 range are usually okay. 300s are dedicated for if something's been moved, relocated, any of that kind of thing, which we're not going to deal with right now. 400s and 500s are error codes. So you've probably seen an error 404 in your lifetime. That means not found. That's one of the error codes that you can return via HTTP status codes. So if that's the case, I just want to error returned HTTP status plus request.status on resource plus URL. So we're just going to send back the error message if it fails to load. If it succeeds, we want to call back with null because there's no error, and request.response text. So we're just sending back the text from the response. The last thing that we have to do is we have to actually send the request out, which we do with that function. So when this method is invoked, all of this is going to execute immediately. It's going to create the request, it's going to open it, it's going to identify what you want to do when that request is finished, and then it's going to send it. So the rest of our code will be able to execute after this is done, but before our resources come back. This callback function, which I should probably use the right name, will only be invoked once we actually do have our resource or if a prohibitive error has happened. So that's going to be a lot more helpful for us. Great, so I'm going to write two more functions really quick, a load image and a load JSON resource, which are going to be very similar, so I don't really need to talk too much about what they're doing. They're just going to handle two different types of resources. I'm not going to worry too much about error handling in the image, just mostly because I'm not sure how I'd like to go about it. So there we go. Now with a JSON resource, first of all, we're just going to be getting the text from the URL. Now the reason that I'm separating this out into a separate function is, just a second, I'm going to finish writing this and then I'll talk about it. So callback, error, else, try to call back on the result parsed as a JSON object. Okay. So a couple of reasons that I'm separating this out into its own function instead of just using the load text resource. Reason number one, reason you should really care about, is that I don't want all of this code, this is like 6 lines of code, every time I have to do a JSON thing. Like this isn't related to the graphics programming at all, this is just converting something that I loaded in text into a JSON object, which really isn't that phenomenal. Second reason has to do with the way JavaScript works under the covers. I know at least in Chrome and the V8 engine there are two compilers. There's an optimizing compiler and there's a general purpose compiler that actually takes the JavaScript code and compiles it into something that your CPU can use. The optimizing compiler will create code that runs much, much faster. And it usually does this on a per function basis, so a function is compiled separately of all the other functions. Anything with a try-catch block cannot be optimized, and so I'm putting that in as small of a function as possible so that our main function can still be optimized better. There's probably other things that are causing it so the other function can't be optimized, but this is just a habit that I picked up while I was doing JavaScript programming over at my last job. Let's see. So now let's go back into our app.js. Let's first start up a server so that I stop seeing all these connection refused. If I refresh it, hello, what's this? Am I not in the right folder? I'm not in the right folder, that's why. cd game programming Indigo CS WebGL tutorials. Now let's set up our HTTP server. So if I refresh it, cool. Great, so you can see we have a rotating cube. I deleted the crate.png, so that's why it's all black right now. But at least we see something. So the first thing I want to do is I do want to separate those shaders. So I'm going to create a new file. This one, I'm just going to call them shader.vs.glsl. The VS stands for vertex shader, and the GLSL stands for Open Graphics Library Shading Language. I'm going to take all this text from our vertex shader. I'm just going to cut that. Use one of my favorite Sublime features to select one of the quotes. Use it to select all of them, delete them, go to the end of all those lines that I have selected, delete the last character, and then just replace that overzealous closing bracket that we have, and boom, vertex shader. Let's do the same thing for our fragment shader, shader.fs.glsl, and that's just there's no reason why I'm calling it .fs.glsl, that's just what I'm picking, kind of seems standard enough, why not? More clear what I'm trying to do. Great. So now one thing I am going to point out is now I've gotten rid of the vertex shader text and the fragment shader text, these two variables. So I'm going to add those as parameters to init demo. Vertex shader text, fragment shader text. And then I'm actually going to make init demo a different function. And I'm going to use init demo to load all of our asynchronous resources, and then as soon as this is finished, I'm going to call this run demo function. Now the reason I'm separating that is, again, if you haven't done very much JavaScript programming, you're not familiar with the concept of callback hell. I'm not introducing any external libraries here, and I'm doing that partially, well, I'm doing that for reasons I've already talked about, but because I'm not bringing in any external libraries, we're going to experience some callback hell right now. You'll see what I'm talking about pretty quick. So I need to load several text resources. The first one is going to be shader.vs.glsl. So this is going to be vs error and then vs text. So what I'm doing right here is I'm calling this load texture resource. This is going to be the URL, and then this is going to be the callback function. I'm defining it right inside of the invocation of this load text resource function. Now first thing I need to do is I need to check to see if there's an error. If vs error equals null, this will be false, so it won't go into here. So alert, fatal error with vertex shader getting vertex shader. Console.error, vs error, c console. Else, so if we succeeded, it's going to come down here, and I'm going to then load our next text resource, shader.fs.glsl, function fs error, fs text, if fs error, alert, fatal error, console.error, fs error, else, and you can see where this is going, because I'm going to be nesting callbacks for every time I need to load a new resource. So if I have 5 resources, I'm going to have this nested 5 times, because at the bottom here I need to call the run demo with the vs text and the fs text, but only if both of these succeeded. Now there's other ways that I could be doing this, but again I'm trying to keep it simple, and so I'm sacrificing good style for simplicity. And if I refresh this, we should see it works the exact same way, which means that we were pulling our vertex shader and our fragment shader correctly. Well, I'm assuming. Let's see. Hopefully it's not caching anything if I introduce a syntax error. Yeah, it doesn't like it. Now, I am going to point out something right here, and that is that Chrome and Firefox. I'm pretty sure all major browsers do this, but they do something called caching, so you probably can't read it. Oh good, I can zoom that in. But you can see right here on shader.fs.glsl, whoops, can I switch away? Yeah. So you can see that on these, what's going on? Okay. A couple of them say from cache. Right now it's only one. What this means is that Chrome actually never loaded that resource, it just remembered it from before. So if I were to go in here and I were to introduce an obvious syntax error, I could probably just something like that. So an obvious syntax error, and if I refresh, okay, so this time it actually looks like it did the expected behavior where it crashed and failed. Oh, well this is turning out to be a pretty crappy demo, huh? Ah, this was working when I tested it before. Okay, here's a good example. Yep. So on the fragment shader, you can see it's loading that from the cache. I can introduce syntax errors up the wazoo, and I would never notice them in the separate file because it's loading it from a cache. Now, there's a couple different ways you could do this. Again, for the sake of simplicity, I'm going to not do it the right way per se, but I'm going to just do a quick little hack. And the way we can do that is Chrome will only cache things if the resource name is the same, so if the URL remains the same. So what I can do is I can add a little thing at the end. If you've ever seen HTTP things before, you can see like I can do a, index.html. If I were to load that, whatever equals 4. This passes in variables, and it's not actually used by the server. It's just kind of ignored. However, the web browser does use it, so I can add that. So some please don't cache Chrome equals, and then I'm going to say math.random. Now if I do that, and I reload, you can see it's still reloading everything, and on all my text resources it's adding a random number to the end here. Is it? That's not what I told it to do. Oh, okay, here it is. Oh, right, that's this. So if I get rid of that, cool. Here you can see it's just adding a random number to the end, so Chrome doesn't cache it every single time. So now if I go back, I can introduce all those syntax errors I had before, and every time it should now crash as expected. So you are getting the right version every time, because we're telling Chrome not to cache. And while you're working on projects, that's very good. Great, so time's starting to slip away, but luckily I think that's all the annoying overhead, and now we can just get into the actual cool stuff, loading the model. So now after I've loaded both of the shaders, I also want to load a JSON resource. What did I call this function? Load JSON resource, go figure. Load JSON resource, and I want to grab this from Susan.json. Model object. If model error, that should be fragment, and this should be Susan model. Else, and I'm not using that right now, but we can at least test to make sure it loads. So I'm actually going to create a global reference right here. Just for debugging. I'm going to remove this before the end of this video. This variable right here. It's just going to help us see it in here. Model object. So now if I refresh that, we should have this model thing, yes, that we can look at. Yeah, so if we look in here, we can see all the information that's attached with it. We're not interested in camera or lighting. Animation could be here. It's not in this particular mesh. Materials, we're not too interested in that because we haven't covered anything pertaining to that. Meshes we are, because we only have one mesh in this scene. We only have one right here, so 0 in the array. And this is going to be our actual Susan model. And we're going to be interested just in the faces and the vertices and the texture coordinates. The vertices are going to be the positions of the vertexes, which we're used to. Texture coordinates is going to be the texture coordinates of each vertex, but you can see it's in separate components. So we're going to have to separate out those buffers into two different things so we don't have to worry about zipping it together. And then faces, another interesting thing, is this is going to be separated into a whole bunch of different faces, each one having three vertices or three indices forming a triangle. Great. So, but we have our model right there, so you can use that for reference. Oh, I guess before we do that, we should load the texture as well. So, Susan texture.png, I believe it was. Image error, image. Cool. I did just call it image, right? Great. So I'm going to add that parameter, Susan image. And instead of using this old crate image, which we no longer have anymore, let's use this Susan image. If we reload that, yes, so we have our image successfully loaded. That's the texture we're going to use for the monkey model when we actually have it. Right now it's on the cube because we haven't swapped out the vertices or indices. So let's find, luckily, in the previous tutorials that I've done, I've called everything having to do with the model itself box something. So I'm going to find everywhere where it says box, and I'm going to replace it with something Susan. So the box vertices, looks like we have two places, so Susan vertices. And then I'm no longer going to use these values. I'm going to use Susan model.models, I believe. Let's check our this. No, it's .meshes. 0.vertices, I believe. So if I were to say model.meshes 0.vertices, yes, that is what I want. So this is going to be our vertices, and we don't have to change how we create the buffer or anything, we're just specifying different vertices. So if we were to reload this, you can see there's a couple of mismatched triangles because this certainly isn't the index list that we're supposed to be using, but it's loading something, and I believe it. Those are about the scale of things that I want to be seeing. So let's change the indices now. Susan indices. So what I did there is I just selected everywhere it said box indices, and I renamed the name to Susan indices. So this is where we get to use something a little bit interesting. I'm going to have to refer to my notes here in order to see exactly how I did this before. We're going to use a quick little JavaScript hack right here, because what I'm interested in is I'm interested in a list like this. It's just a list of numbers, but what we're going to get is we're going to get something more like this, where it's an arrays of size 3. So let's see, so model.meshes0.faces, I believe it was, yes, gives us that list. A little hack you can do, I'm not going to explain why this works, is if you say empty list.concat.apply empty list, your list of lists, and that's it, then that returns a list of all of them put together like that. So we're just going to do that right up here. .concat.apply empty array Susan model.meshes0.faces. Cool. Now if I reload this shouldn't work because we don't have our texture coordinates in place yet, so yep, out of range. So what we're going to do now is we're going to really quickly fix this, because our vertex arrays are now using 3 instead of 5, and we have an additional 2 that we'd like to introduce. Actually, first let's get those lists. So, where did I go? Var Susan text chords equals Susan model.meshes0. What was it? I think it was texture coordinates. Texture chords. Texture chords. And this one also, it accommodates multiple textures. We're only using one, so we're only interested in this first array, and then this is going to be all of our UV locations. So load that into our Susan text chords. Oops, I don't want to save that. Great, and then let's create a separate buffer for that. So right here we have box vertex buffer object. Let's say Susan vertex buffer Susan pose vertex buffer object. That is a very Java sounding name, isn't it? And let's change this while we're at it too. Susan index buffer object. Great. And then let's also create one for our text chords. Buffer object equals gl.create buffer, gl.bind buffer, gl.array buffer, Susan text chord, that thing. So one thing I'm going to point out again, like I said, OpenGL is a state machine, so every time you bind an array buffer, this becomes the bound array buffer, and any other operations on an array buffer get acted on the last bound buffer object. So for this one, we bound a buffer and then immediately set the data. For this one, we're going to do the same thing but with a different buffer. So we're going to set the data. Again, it's a float32 array, Susan text chords, and static draw. Now, one thing that we have to be careful about is all of these used the position buffer before. So I'm going to move this. I'm going to separate these so that they're actually together. So now we have everything having to do with the vertex attribute location for, or the vertex attribute for the position. I have that separated from the texture coordinates. So I'm going to here bind the buffer, the Susan position, and then down here before we do our texture coordinates stuff, I'm going to bind the texture coordinate buffer, Susan text chord vertex buffer object. Great. So now this is going to be applied to the position vertex buffer, and this is going to be applied to the texture coordinate buffer. I'm also going to change these really quick because we don't need. They're all only going to be containing elements about what they describe. And if I scroll down, I do believe that is everything that we had to do. Yep. So if I look for box, oh, we have just box texture again. Susan texture. Do you have any other instances of the word box? No, we do not, so it looks like we swapped out everything with box. If I refresh that, great. So we have Susan, but as you can see when she turns back around, something is horribly, horribly wrong. The eyes are straight black, which is not at all what we intended. The reason for that is, if we open up our Susan texture.png right here, I imagine what ended up happening is for the FBX file format, it was exporting for perhaps DirectX instead of OpenGL, or maybe some other thing. OpenGL does its texture coordinates with 0, 0 starting in the bottom left, whereas other ones may start in the top left. So I imagine it's just thinking that the eyes, instead of being in the bottom right corner, should be in the bottom left. So if I were to open this up in Paint, MS Paint, so I'm going to show you two ways to do it. I'm going to show you the wrong way first, and then I'm going to show you the right way. So this is the wrong way. The wrong way would be to create a new texture. Yes, I don't care about transparency. Just flip it around the vertical axis, save it. That's Susan texture2.png, and use that instead. So here we are, we loaded it, and look, the eyeballs are the right color. Yay, wonderful. However, that, especially if you're working on a game or a large project, that is going to take a lot more effort than it's worth, so I'm going to call that the wrong way. The right way is that you can tell WebGL that I want to load things, that I want to load all of the resources flipped around the y-axis, so upside down. And the way you do that is over here, when you're actually binding the texture and you're adding the information, you can add a parameter to the texture loading process using the gl.pixelStoreI. And here I want to change the property unpack flip y WebGL, and I want to set that to true. So this is just going to say flip around the y-axis when you load it. If I load that, boom, it works. And just to prove that it does and that I am loading the new one, if I comment out that line, it's got the black eyes again. Great. So that is everything for this tutorial. I will point out I am well aware that this is just like an amorphous blob of brown right now. That is because we haven't introduced any concept of lighting, which is one of the things that does incredible strides for separating between photorealism and amorphous blobs like this that you see. I'll be introducing that in the next tutorial, so go ahead and watch. I'll be posting that in the next few days, hopefully. Hope you enjoyed this one, and let me know in the comments if there's anything specifically you would like to see. Thanks for watching.